Here we're trying to do some more optimization, finding absolute maximum or minimum. We have the daily average cost function in dollars for this electronics company is given by C bar equals 0.0001x squared minus 0.08x plus 40. That is as long as x is bigger than 0, where x stands for the number of graphing calculators that this company produces. Find the level of production that will minimize the average cost for the company and figure out what that minimum average cost would be. So we're looking at average cost. So a nice opportunity to do a little review. Average cost is always labeled C bar of x, and it's found by doing C of x, the total cost divided by x, the number of graphing calculators, or calculators in this case. So we want to minimize this function that we're given. So we want to find the absolute minimum. We're going to do our two steps. First step is going to be to take the derivative of C bar. So we're going to call it C bar prime. And we're going to bring down the power. We're going to have 0.0001 times 2 is going to be 0.0002x. And then the derivative of negative 0.08x is negative 0.08. And the derivative of plus 40 is 0. It's a constant. We're going to set that equal to 0. The nice part about these word problems is it's a nice linear function. So we're going to just be able to add 0.08 to both sides. So we're going to get 0.0002x equals 0.08. And now we need to divide both sides to try to get x by itself. So we're going to divide both sides by this 0.0002. So we're going to get x equals 0.08 divided by 0.0002. X is 400 for our critical number. So that is 400 graphing calculators. That's what x represents in this problem. And we want to compare that to our endpoints. So our second step, we know they have to produce more than 0. So we're going to do C bar of 0 is their lower bound. But we're not given an upper bound. They haven't decided or calculated how many they can make in a day for this daily average cost. Maybe it's kind of open-ended. They could hire more employees as needed or have longer shifts, maybe have a first and second shift staffed. They don't have an upper bound for the number of graph calculators they could possibly make in a day for this daily average cost. So we have no upper endpoint. So one thing is we can definitely test 400 because it doesn't say, hey, they can only make between 0 and 150 graphing calculators. So we'll have to test that, see what that y value is. And then we'll also have to make a sign chart. We're missing one of our endpoints, which tells us we have to make a sign chart. We're going to put our critical number on there, which is 400. That's what makes C bar prime equal 0. And so we're going to test that critical number with the numbers around it. So our critical number is we can choose any number to the left. It might not make sense for them to produce 0 graphing calculators, but we can still test it just to see what's happening with the derivative. So I'm plugging into my derivative. I would have 0 minus 0.08 when I plug in. I would get a negative when I plug into the derivative. If I plug in 500, could use my calculator if I need to, but if I plug in 500 to my derivative, I'm getting a positive number out for the derivative. So I'm decreasing and then I'm increasing, and I have a 0 derivative at that critical number. So I do have a relative min, and comparing it to my end behavior of this whole graph, this is the shape of what it looks like. It's decreasing, it has a 0 derivative, then it's increasing. Is that relative min also going to be an absolute min? Yes. It's both a relative and an absolute min. So we could compare these y values as well if we wanted to. So if we plug in 0 to the original function for that y value, we'd get 40. Of course, it says they want to make more than 0. Obviously, to try to make money, they have to produce some graphing calculators. If we plug in 400 to the original function to see what its y value is for that relative and absolute min, it is both, the y value is 24. And there's no upper endpoint. So we saw on a sign chart, we would compare it to the end behavior to the right, and that relative min is also an absolute min. So what we get from that is just some confirmation. We're looking for the absolute minimum in this case because we're talking about average cost. So we want to make costs go down. So we would say they should produce 400 graphing calculators for an absolute min average daily cost of $24 per calculator. Quite the mouthful. They should produce 400 graphing calculators because that's going to give them their absolute min average cost each day that they do that. And it's going to be $24 per calculator. So that's great to know when they're trying to price out these calculators, especially a graphing calculator. We know that those can sell for around $100. So if they can produce 400 a day, that's the sweet spot. That's where it's costing them the least per calculator. So their average cost is down to $24 per calculator, and then they might be able to hit the market and sell these things for anywhere between like $85 and $120.